Okay, in this video I'm going to try to graph this exponential function here. I know it's an exponential function because the variable x, the independent variable, is in the exponent. To graph this, I'm going to start with the parent function or the parent equation. That for this one would be y equals 2 to the x. And I call this the parent equation because this equation can be generated by doing transformations to this equation. Specifically, since it's x plus 1, I'm shifting this parent equation to the left 1 and then down 3, this minus 3. So it helps to start out by getting a graph of the parent equation y equals 2 to the x. Now for exponentials, there's some basic points that we use of the parent equation that we plot. And the first one is when x is 0. So one of the basic points is when x is 0. If I raise 2 to the 0th power, 2 to the 0, believe it or not, is in fact 1. I'm going to go ahead and defer to the calculator on this one, as it seems to be commonplace to argue with me about this concept. However, for some reason, there's infinite trust in the calculator. So 2 raised to the 0, you will see is 1. In fact, any number, any real number raised to 0 appears to be 1. Let's even see what happens when we type in 0. Except for when we type in 0, then we run into a problem. So we will exclude 0 from that statement of any real number. But, negative 1, or let's try negative 3 to the 0, again, is 1. So 0, 1 is one of our basic points. Another one of our basic points is when x is 1. Okay, if I plug in 1 here, I have 2 to the 1, which is 2. And if I want to, I could plug in some other values. I could plug in x is 2, and 2 to the 2 is 4, and keep going, so on and so forth. But having these 2 points is essentially all I need. But if you want, you can do more. Now we also need the horizontal asymptote. And the horizontal asymptote for a parent equation of exponentials is y equals 0. And essentially that results from the fact that this graph will never uh, be 0. And as I go to the left, as I make this x value negative, I will get 2 to a negative number, which inverts this to 1 over 2 raised to that number, and it just gets smaller and smaller and smaller as we go to the left. And we'll see that when we graph this equation in the calculator. But let's talk about, let's go ahead and get a quick view of this graph, of this parent equation. This is not what I'm trying to graph. This is the equation of the parent function that I want to graph. So here's my x-axis, here's my y-axis, and I have a horizontal asymptote at 0 is what I'm claiming, and then the graph passes through the point 0, 1. So in blue here, 0, 1 would be about right here, and it goes to the point 1, 2, which would be about right here, and it has the horizontal asymptote. So as it goes to the right, it grows exponentially, and as it goes to the left, it gets closer and closer to 0 without actually touching 0. So this is just the graph really, really close, hugging the x-axis. And this is the graph of the parent equation. So now what I need to do is apply the transformations. And the transformations for this function, as we can see, is left 1. So I'm going to go to the left 1. And I'm going to go down 3. Down 3. I'm just going to use some quick notation so that we can get from here to the new points. So if you can imagine, I'm taking this graph right here and I'm going to move it left 1, so move all the points left 1, and then I'm going to move all the points down 3, and you can visualize this graph moving uh, left 1 down 3. But let's look at see what it does to the points. So if I take this point 0, 1, and that's this point right here, and I move it left 1 down 3, the new x will become negative 1 because it went to the left 1. And the new y, if I do 1 minus 3, that'll be negative 2. Okay, and likewise with this point, if I move it to the left 1, the new x is going to be 0, and the new y will be negative 1. Now let's think about this horizontal asymptote. If I move this graph to the left one, notice that doesn't affect the horizontal asymptote at all. If I move this whole thing left one. But when I move it down 3, it takes the horizontal asymptote down 3 units to y equals -3. Okay, so I have enough information to finally graph this function using the parent equation and then the transformations to the parent equation. So let's look at that over here. I'll try to keep it on the same, well, the same scale might be difficult, but maybe we can pull it off. So here's my x-axis, and here's my y-axis. And I'll try to use the same scale. If this was +1, then this would be -1 down here, -2, and -3 is my horizontal asymptote. So here's my horizontal asymptote. Right? And one of the points is -1, -2, so -1, -2 is approximately right here. Other point 0, -1, which is approximately right here. Alright, and the graph just keeps the same behavior as it did before. It's just been translated to the left and down. Okay, and that's a good view of this graph, and as you can see, the shape of the graph is the same. Now, of course, if we have a graphing calculator, which we do, we should always confirm our results in the graphing calculator. I have something that says f of x equals, and the first thing I should think of is going to y. And I'm going to type this graph into y equals to confirm the results. This is 2 raised to the power x plus 1 minus 3. And if I look at this graph, yeah, I can see this graph right here is essentially what I have. Okay, in the next video, I'll start answering some of these questions about this graph, about domain and range, and the asymptotes, and so on and so forth. But for starters, we've done a pretty good job of getting the actual graph, which is of the function, which is right here.